Hello, middle school math enthusiasts. The objective of this video is to review some of the exponent laws and then do a couple of examples when it comes to multiplying with exponents and coefficients. I'm assuming right now that you are pretty comfortable with the product law, the zero exponent or zero power law, how to perform a power to a power, how to use exponents when performing a quotient, and how to manipulate negative exponents. All of those will come into play in some of the problems that we do with coefficients. First, let's go to just some examples and to kind of keep things straight and organized. Coefficients are numbers that are multiplied by variables. They can be positive, negative, they could even be fractions. For example, 3x. The 3 is the coefficient of x. We could even say like 1/2 xy squared. The xy squared are the variables, but the 1/2 is a coefficient. And something like even like -7 mc squared. We don't know what the m and the c are, but we do know that the coefficient of that term is the -7. So now we're going to perform some exponent properties and some exponent exercises with coefficients. You're probably used to multiplying n to the 6th times n to the 4th, but what happens when it's 3n to the 6th times 2n to the 4th? Well, I would gather the whole numbers or the coefficients together, because everything in this expression here is being multiplied. Even though there isn't a dot there, it's really 3 times n to the 6th times 2 times n to the 4th. So you can rearrange those terms when they're being multiplied because you can commute under multiplication. So the 3 and the 2 can get multiplied, and gather the n's, n to the 6th times n to the 4th. 3 times 2 becomes 6. And n to the 6th plus 4th uses the product law. That's n to the 10th. Similarly, 8c to the 11th times 7c to the 7th, I can multiply 8 times 7, c to the 11th times c to the 7th. I put them all in one line, and then I gather the two terms in groups. 8 times 7 is 56. And then c to the 11th times c to the 7 is c to the 18th. You just got to remember that these coefficients, they do get multiplied, and this c to the 11th and c to the 7th are really being multiplied, but when that happens, the exponents are added, because we could write it out. That would be 11 c's multiplied times each other, and 7 c's multiplied times each other. Altogether, that is 18 c's multiplied times one another, and that's where we get 56c to the 18th. The pattern for this, for the coefficients, is you multiply them. I'll highlight where that happens. The coefficients were 3 and 2. 3 and 2 get multiplied. The coefficients were 8 and 7. 8 and 7 get multiplied. All right, let's switch colors here and go to the power to a power. It's kind of one of my favorites, because what does it mean to raise a power to a power? Well, in this case, when you square something, I would use my teacher parable or my teacher adage, when in doubt, write it out. To square something really means to multiply whatever is inside being squared times itself. 5t cubed, that's 5t cubed times 5t cubed. And now we're kind of just where we were with the product law. We can gather those 5's. I'm going to put an arrow here and say it's 5 times t cubed times t cubed. Then that becomes 25t to the 6th. Now right here already, you might realize a shortcut, that when you have some expression that has both a coefficient and a variable in there to a power, that power gets kind of distributed. So this 5 gets squared, and the t cubed also gets squared. So it could be like this: 5 squared times t cubed squared. And you just got to be careful that we're squaring something again. 5 squared is 25, and t cubed squared really means t to the 6th. If in doubt, you could write it out. 4g cubed to the 3rd power. I'm still going to, since this is a 3rd power, it's okay to write it out. If it was like 7 or 8, that would be a little tedious, and hopefully I'd know the shortcut before then. But I'm just going to go, okay, that's 4g cubed times 4g cubed times 4g cubed. I've got some variables, these coefficients there. I'll gather them. That's 4 times 4 times 4, or 4 cubed, haha. And this is g cubed times g cubed times g cubed. All together now, 4 times 4 times 4, that should end in a 4, that's 64. And g cubed, g cubed, g cubed, we would add those exponents. We've got 3 of them, 6 of them, g to the 9th. The pattern here, when it comes to the coefficients, is you raise those coefficients to a power. To a power. You'll notice that 5 was the coefficient and 2 was the power. The result is 5 squared, or 25. 4 is the coefficient, 3 was the power. It will be 4 cubed, or 64. All right, how about green? Quotient. Quotient is a fancy word for saying dividing. And we kind of have to operate separately on these. 3g to the 6th over 9g to the 4th. We say them all together, they're 3g to the 6th. But my suggestion is, because these are being multiplied and they're under one division sign, because of the rules of division, you can separate them into the coefficients as a quotient and the variables as a quotient, and just treat them separately. 3/9 is also known as, let's see, 3 goes into 3 once, and it goes into 9 3 times. We're looking at 1/3. And g to the 6th over g to the 4th, the quotient rule says that you can subtract the exponents, or I like to think of the higher power winning. In this case, the 6 is the higher power in the numerator, and it's going to win by 2 g's, g to the 6 minus 4, or g squared. 1/3 g squared. Or you could write it as g squared over 3. 1/3 g squared. Either of those would be correct. 12f to the 9th over 6f to the 5th. I treat them separately. Know that you can separate them, but they're still going to be combined in the end. 12 over 6 and f to the 9th over f to the 5th. 12 over 6, hey, that's just 2. And I'm just going to write it as 2 over 1, because I know that there's probably still going to be a fraction, and I just want to keep things tidy and not forget that this is a fraction, and the other part may have a denominator. 9 f to the 9th over f to the 5th. Oh, that is f to the 9 minus 5, or f to the 4th. In this case, f to the 4th is over 1. My result is 2f to the 4th. Does not need a denominator of 1. Now the pattern here when it comes to a quotient is you divide the coefficients. 3 is divided by 9 in the original problem. That results in 3 over 9 is also 1/3. 12 over 6 is the same thing as 2. So you divide the coefficients. I'll put divide them. Now in the next video, I'm going to go over a couple of examples. They're probably ones that are combinations of them, what we'd call like multiple properties, kind of a challenge. So tune in for the next video if you'd like to see some of those work.